Okay, what we're looking at now is a completely assembled Flatliner and cart with all its components and whatever set up ready to go. Now what we want to do in this video is talk about best practices and health and safety issues with the system itself. Now it is important that we take note of what I'm about to tell you, because it will increase the longevity of the equipment itself. Like any piece of equipment, it's susceptible to abuse and misuse, and unless you're armed with the right information, this equipment, like any other equipment, could deteriorate quite quickly. With the DigiSpot itself, when the cable goes in, we push it in and turn clockwise and lock it into position, and then we put the plug for the manual auto function into the female socket. That's now ready to go. But what is important, when we remove it, there is a tab on the top that we have to depress or push in and then remove the plug. Okay, at all costs, avoid just trying to pull it out, because all that happens then, it will pull the guts out of the female plug itself. So push the tab in and remove the plug. And when you're removing the cable itself, opposite, anti-clockwise. With our welding unit, it is important that you do not have pacemakers or anything fitted like that, because it is an electromagnet and it can affect a pacemaker. So that is the first most important issue. The other issues are it generates heat. As a welder, naturally it will generate heat. So there are components that we use within this system which generates more heat than others. So this is the first thing we're going to look at. Up here we're storing the carbon shrink rod. Now traditionally you could light that anywhere on this cart, but it is made of carbon, very brittle. And also, again, when you're doing a repair, this is designed to produce large amounts of heat and can heat up a panel to red hot. So every time we finish using this, we take it straight off the large slide hammer cable and slot it up there. That way no one can get burnt and it's out of the way and it won't get broken. Also, when we do perform a repair, we have to make sure that the panel being worked on is completely free of anything that's flammable on the rear. So there is a case there for stripping out the panel, or anything according to methods must be followed. Okay, moving on from that, we're also going to look at the T-bar. Now there are health and safety issues with this as well. If we're doing pulse shrinking or what have you, that will generate lots of heat as well, and will also transfer heat up the shaft itself. So we need to be aware that we minimise the amount of shrinks that we use with that, and we like to go somewhere around six shrinks and then allow it to cool down. But one of the issues with this, when we're pulse shrinking, is the amount of heat that's generated through the cable as well. On this handle, you've got a flexi area there, and if you get too much heat up through that handle, when you break the welds, you naturally start to get deterioration in the cable. If you note, on these hooks here, you'll see the spring for the inner puller and the chrome collar for the inner puller. Now, I like to keep them there, and I find it's the best place to put them. A, you always know where they are and they're not rolling around on the trolley, but B, because they get used quite a lot, they're very easy to get hold of and quick to hand. Maintenance of the large slide hammer is important. Just be constantly vigilant with what's going on, because this is designed to do all the heavier work. Ultimately things are going to start to shake loose. So first thing to be aware of is the grub screw in the end. Must always make sure that is tight. And secondly, in this top bracket here there is a high tensile split pin or sprung pin, and with the constant knocking that can work itself out. If it starts to appear from either end, tap it back in, make sure it's in place. Otherwise it will eventually come out and you'll elongate the hole in the shaft itself, and then it won't fit back in. We're going to take a quick look at these bridge bars or pull bridges. When we're actually using these, it is important that once we've manoeuvred our feet into position and the pulling system itself in the centre, that it is locked, and these are locked. Now this gives the bar strength in the centre if you're doing a really strong pull, and these give the legs rigidity. If you was to leave these loose, there is a tendency for the thread to bend. So if you're under a lot of pressure, this bar itself could start to bend, particularly if you're not locked in. As we showed on the assembly video, there's a locking in recess there, which gives it its strength. So if you had it sat outside and tightened it up, it then becomes weak, and you could, on an angle, actually bend that bar. Once it's all locked into place, it's very, very strong and will not move. Like the FL120, talking about locking these up, it's the same scenario with this, but one thing that's really important is that before you start manoeuvring this into position, make sure you've got them locked up. It has happened, and it has happened to me as well, is that if you lift that up in the air to do an upright pull and that's loose, that will slide down at a rate of knots and hit your hand, and it's not very pleasant. Another option on the FL80 particularly is the multi-directional knuckles on these legs can be removed. Now I find it more beneficial to take these knuckles off. So we undo this nut and bolt, and there's the same nut and bolt on the bottom here. Remove that universal joint and then bolt this foot directly to the bottom of this leg, and what that will do will allow it to only move one direction and be rigid the other, and that makes it much more flexible when you're doing a repair